Good morning all, lots of post, so it's Postbag. Okay, let's start with this one. What could it be? Hopefully no more late night eBay shopping. And they're neodymium magnets, quite a lot of them, pretty thin, look like 1mm thick. Now I think the reason I bought these was to hold the two plates of a homemade supercapacitor together, so I didn't need to use clips. And the idea was, and I'll show it on the modified supercapacitor idea, which is these business card things. I think the idea was to put one magnet one side, another magnet on the other side of it, so they hold each other together. Then you put a magnet the reverse way round, and then you put another magnet on the other side. No, that's not right. So that one goes there. This one goes the reverse way around and sits on that one. And you can build up by continuing this process. Oops, it's difficult because they just want to sort of jump on top of each other. But you can, if you're careful, build up a complete matrix of these things. Yeah, and then I think that will sit there. Let's try and get a fourth one in. Is it that way around? No, that's pushing. Yeah, and then I should be able to get a fourth one on the other side, as long as I get it the right way around. And just continue on like that, building up a matrix of these magnets. Of course, each one of these is reversed relative to its neighbour, and then you've got them on the other side, and just build up a complete set on either side, providing a lot of sort of holding together force, which if I pull these apart will immediately break. Yeah, what fun. Now it'd be interesting to see if these neodymium magnets end up like my other ones, which are all broken because every time I snap them together little bits break off, and there's obviously some magnetic gunge in between these two because they're not sitting closed properly. So will these end up like these? And these magnets also make good battery terminals for attaching wires to batteries. Now what I tend to do is take two of these, trap my wire between them like that, and then attach it to the battery terminal. But that's a bit of a temporary solution. I did wonder about soldering to these, whether or not they can be got hot enough to actually solder a wire onto them. I might try that at some point. So let's store these magnets with my other ones. I just stick them onto this metal filing cabinet. Perfect. And so these are 100 pieces, 10mm by 1mm neodymium disc super strong rare earth magnets. These were $5.63 for 100, free shipping, and they came from Yao Li Hong 2013. Right, what's in this one? Oh, a monster capacitor. Let's have a closer look. So yeah, this is allegedly a Samwa green cap EDLC. That's an electric double layer capacitor. I don't know what dB in brackets is. 2.7 volts, 500 farads. Now interestingly, it's got 4 terminals. One of them's marked positive. That is next to the negative band, but I'm not sure what these two do. So perhaps I could work that out with a DVM possibly. But it is physically quite large. Let's put it alongside some of the other supercapacitors I've got recently. So you can see that relative to this 100 farad, well, let's turn them around, this 100 farad NES cap, 2.7 volts, this is probably about 5 times the volume, so that would make sense. The 100 farad is approximately the same size as the 120 farad capacitors on this capacitor module that I bought recently. They're comparable size. And here are the 2.5 volt 220 farad capacitors that Dacian sent me the other day. These are power burst, and although they're about the same length as this 500 farad, obviously there's a difference in the cylindrical diameter. So let's see what these 4 pins are all about. So if I put negative on that one, I'm in voltage mode, aren't I? Yep. So positive, and I've not got much voltage, about 120 millivolts. What's that one? That's interesting. That's falling rapidly. Maybe there's very little in there. I wonder if these are separate capacitors or just... Oh, that one's negative with respect to the negative connection. That one's definitely positive and holding 120 millivolts. This one just seems to decay away rapidly. I wonder if there's some data on this capacitor. Well, I found a Samoa green cap PDF, and this one here looks similar. It seems to have multiple pins, 2.71 volts. This one says 360 farads, and in the list of available items they only appear to go up to 400 farads. Now I don't know whether this might be an old document, but there's no guarantee, of course, that the capacitor I've been sent is genuine. But there's nothing in this PDF relating to what these 4 connections actually are, so I'm really none the wiser about that. So this item, as described on eBay, is a one-piece farad capacitor, 2.7 volts, 500 farads, 35 by 60 millimeters supercapacitor. This was $4.49, free shipping, and it came from Quotop 2014. Right, this one I opened recently in another video because I wanted to just show this device, which is a buck boost converter with an LTC 3870. Pretty sure that's what that is. But before I come to that, I want to take a look at this item. Is that open? No, I'm going to have to cut that open. Right, this one just reminded me when I got my DVM out just now that I had this, and it's one of these precision voltage generators. Interestingly, it's got an input on a 2.1mm socket, and I seem to remember that it takes something like 11 to 15 volts, which is absolutely perfect for plugging my solar power system directly into there. That's what I liked about this, because that'll be about 13. Oh, it's 13.1 at the moment because there's no sun. That's interesting. What's that? Is that just a packing note? Oh yeah. Oh no, it's actually some data. Yes, you get 4 voltages, 2.5, 5, 7.5 and 10 volts. And I think you can put a battery in there, but it's one of these sort of strange voltage ones. I can't remember what it is. I think it might be 12 volts. Anyway, I'm going to plug in. Well, I'm just going to check on eBay first that it's safe to plug in my 13 volts. And then see what voltages we get out of here. And see whether my... Well, obviously they're going to be accurately these. And see whether my DVMs are calibrated properly. Right, my one's dropped off my purchase list, but I did buy it from Alice, so this is the exact same one. It's based on the AD584 high precision voltage reference module, 4-channel, 2.5, 5, 7.5 and 10 volts. This is currently $5.52 free shipping from Alice 110 1983, but I want to see what's involved in powering this thing up. So there's quite a lot of data here on Alice's listing. And operating voltage 4.5 volts to 30. So it has a really wide range. Of course, you need to put in more volts than the value you want to get out. So for the 10 volt output, you need to put in, well, there's probably an overhead. Now it says here onboard 15 volt battery. Battery is the lowest noise, blah, blah, blah. So that's an interesting battery. I'm not exactly sure what type that is. Probably says here somewhere. But certainly it seems I'm safe to put 13 volts into this. And I'm going to start looking at these outputs. Well, it looks like it's currently linked for 10 volts. It also looks like you probably have to move both these links over to another block to get the other voltages. But let's start with 10 volts. So let's put my 13 volts. Actually, it's 13.5 now because the sun appears to have come out, and hope it doesn't go bang. Just quite a big fuse in this line, 3 or 4 amps I think. So tiny little red LED is on there. And now let's poke my probes in, make sure that's on voltage, into these things here. That's the pos. Oh, they fit really well. So it's obviously designed to take meter probes. There's the neg. And that's precision 10 volts. Oh, my meter's quite a long way out, isn't it? 10.02 it says. Now it does say here, before detect multimeter and board warm up at least 30 minutes at room temperature 25 degrees, which it is exactly 25 degrees today, to ensure that the detection accuracy, each board at the factory to be detected with an Agilent 6-digit multimeter and marked with the output voltage. Now I think that's what's written on that piece of paper that I got. So I think these are the test results from this actual module. 5, 7.5 and 10 look pretty good. I'm not sure what these voltages are. Possibly the voltage range that it was tested on, I don't know. But the 2.5 measured 2.499. So if I was to do this properly, I'd probably have to leave that for 30 minutes for the chip to warm up. Although it's been in this room in that bag, in that padded bag, so it should be warm. But yeah, I ought to wait for 30 minutes before I'm going to get an accurate reading on my DVM. What I could do though now is try my other 2 DVMs, because I've got 3 of these. So that one is 10.02. Let's pull the probes out and put another one in. See what this is. It's common and voltage. That one's 10.00. Much better. Okay, let's take these out. Now these are only to 2 decimal places. Anything above 4 volts I think, so probably get, it would be a better test. Volts, yeah. That one's quite a bit on the low side. 9.94. These aren't very well calibrated at all, are they? But what I'm going to do is I'm going to put this down to 2.5 volts, because at 2.5 volts on here we get 3 decimal places. Now I'm not sure whether you're supposed to relink this while it's on, but I suppose I could turn it off. Okay, let's move these links right over to 2V5. One of those pins is a little bent, I think. Switch that on and put the probes in again. Well, now I've forgotten which meter is which, but anyway, that one reads 2.501, so that's not bad. This one is 2.487, so that one's the one that's a bit on the low side. Let's put that there. And this one is 2.510. So I suppose what I could do, if there are pots inside here to make adjustments, is I could use this as my master definite voltage source and calibrate the meters to that. Now what about this 15 volt battery? I've done a Google search for 15 volt battery and we've got this one here. It's a BLR 154 15 volt multimeter battery, £8.03 from Rapid Electronics. Let's type in that BLR 154. And here's the small battery company. They call it an A220 or an Everready 504 or a Rayovac 220 or a BLR 154. It's alkaline, 15 volt. So it must be multi-cells stacked up in there. Length 34.9, so about 35 millimeters. Diameter 15.1. And they want £9.50. So one of these meters is quite accurate, the others aren't, but which one's which? Put a sticker on it? Definitely not. No, I'm going to have to calibrate the ones that aren't correct so that they're all the same. And just for amusement, let's check one of my sino meters. These were £3 each, I think. I won't put it on the 10 amp range, that would be a bad idea. So this is on 2.5 volts. Seems a bit of a bad connection, but oh, that's pretty good, 2.49. Nothing wrong with a sino meter. Now, just a brief mention about this LTC 3780 module. This is a buck boost DC to DC converter. So I've got my 13, oh, it's 14 volts now, 14 volts going in. And you can see we've got 12 volts coming out. I think these are generally preset to 12 volts. But the thing about buck boost is that you can have either a lower voltage coming out, if I turn this anti-clockwise, or you can have a higher voltage coming out. I can't quite remember what the specs on this are, so we'll take a look at the eBay listing on that. Now, I'm not going to go into any great detail on this because I have done that before. What I'll do is I'll put a link in the description to the video I did on this module. It was a slightly different layout to this one. When I find my other one of these, I'll probably do an update video on this. Just one thing I do want to say is that I've looked on eBay for modules that have this chip because it's a very clever chip. It's a synchronous buck boost converter, but with a digital front end, and I can't find any. There is one that has this chip with a built-in voltmeter and ammeter, but not a full digital front end. Oh, and something else. This comes up time and time again. People say, what's that thing you use to twiddle the little 10-turn pots? Well, this one is an original Bourne's trim pot, which I was given when I started field service engineering in about 1985. So this is an old one. But if you want something similar, if you look on eBay for a Bourne's H90 or an H91, you'll find something very similar, which has a recessed screwdriver at one end and a slightly protruding blade at the other. Now, this is another one that's dropped off my purchase history, but I did buy it from Alice, and you can see that Alice is still selling it. There are two types here. This one is a 3-pot, so it has constant voltage, constant current, and also an undervolt. What would it do? Drop out? Yeah, I think yes. If the input voltage goes under a certain voltage, then this can protect the battery, as it were, and just switch off the output. I think that's what it does. This one, slightly different layout, and it only has one pot. You can just see it there. It's just for a voltage regulator, doesn't have constant current. But this is the one I bought, $14.20. Let me just click through to that item. Yeah, 5 volts to 32 volts on the input. You can see that there are 35 volt capacitors, so that's a limiting factor. 1 volt to 30 volts on the output, up to 10 amps allegedly. There are 4 MOSFETs sitting underneath these 2 heat sinks, based on the LTC 3780, automatic, not sure why, step up or step down, regulator charging module. Charging module, I suppose, because it's got the constant current pot. So this one is currently $14.20, free shipping from Alice 110, 1983. Wow, low leakage capacitors on this thing. That blue LED's been on for a good 10 to 15 seconds after I disconnected it. Nice. Right, let's do another one. Oh, I didn't even cut that. This knife's so bad now, it's broken and completely blunt. Time for a new knife, I think. But let's see what's in here. What's this? Oh, it's another watch. Oh, actually, I think this one's quite an interesting one. This is a smartwatch, an LCD colour smartwatch, if I remember rightly. Why is that showing? I think they've got two. Yeah, they've got two protective covers. That's a bit weird. I can't make it do anything, so I'm guessing the battery is flat. It appears to have buttons down there. Maybe they're touch switches. So I'm just going to plug that into a power bank. Did it come with... Yes, it did, I think. A USB lead. So let's get that powered up. Right, let's see if it does anything when I plug the USB in under this flap. Which way around is it? That way around. Oh, go on, get in. That's it. Any evidence that it's doing anything? That's on. Oh well, it doesn't seem to do a lot. And there's no actual light to show it's charging. Tell you what, let's see if it's drawing some current. Using this voltage and current detector that I bought the other day. Let's plug that one in. .2 volts. Oh, it is drawing some current, 0.26 amps. What's happened to my focus? Ah, and now I have a very nice green charging icon. 5.11 volts, 0.75 amps. So yeah, it's drawing a fair old current. Will it switch on now? Yeah, and it makes a pretty song and says welcome. Thursday, 1st of Jan, the Bluetooth has fired up. Now I think what you do with this is you load an app onto your phone, and then this watch talks to that app, steals all your data and sends it to an unknown IP address. Or at least that's what the news stories have alleged. So here's a piece on mobipicker.com from March 2016, which says U8 smartwatch makes secret communications with Chinese IP address without users knowing. And the picture of the watch they show does look, well, almost identical to this one. Possibly the only difference being this one has a black button, but the strap is the same. So this is almost certainly the watch they're talking about. And it says here the IP address was unknown and an encrypted channel was handling all the traffic. As a result, the researcher couldn't exactly find out what app was sending out to the IP. Neither the U8 website nor the manual of the watch seemed to provide any hints about what was happening. It is possible that it might be simple telemetry data, but it also could be at worst as the contact list or photos and videos and messages of the user. So I probably won't even bother to load up the app on my phone that this thing communicates with, but this is pretty amazing. I mean, it's all touch screen, user interface. No, I want to go into settings, clock, time and date, set date. So it's a really nice display on here, probably eats the battery, and it's a touch display. It's got Bluetooth, it's encased in quite a neat package, but yeah, I think probably I won't bother to use it because it's not going to do anything very exciting, is it? It's not a smartwatch like an Android Wear or anything that's going to do stuff related to my Android operating system. So I think really all I'm going to do with this is just take the back off it, pull all the guts out and see what chips are in there, what's doing the Bluetooth, what processor it's got. But yeah, it's quite nice. I quite like that. Bluetooth. Search new devices. Oh, go on then. Searching. What's it going to find? Should find my phone, I guess. It's not finding anything. Stop searching. Back. Yeah, I mean, in terms of technology, it's a really nice thing. But no, I don't now dare run the app on my phone. So we'll just see what's inside it. But I'll do that another day. Oh, I've just managed to set it to an analog clock. Let's go back because there was a settings, clock type, analog 2. What's that one look like? They're quite nice, aren't they? Now the manual doesn't really tell you a lot. In fact, it just has these QR codes in it to enable you to download the app that works with this watch, and then presumably the watch talks to the app, and I imagine it'll do things like vibrate when you get emails through, but nothing that I'm going to find very useful. No, I want to see what's inside this thing. So this is the item on eBay. It's a Bluetooth smart wristwatch phone mate. Now this isn't the one I bought. Mine was $8.99. This one says $5.98, but there is some shipping on this, so actually when you add this up it's more like $10. That's the sort of price these go for. I got one for $9. You may find one cheaper than this. That's if you dare actually load the app onto your phone. This particular one is from Good Does 11. And so that's it. These are today's Postbag items. Cheerio.